Alright, this is Chapter 10, Lesson 2. We'll be talking about biased and unbiased samples. As we're doing statistics, getting a sample is not as easy as it seems. In fact, it takes quite a bit of planning, quite a bit of thought to get a correct or a good sample that gives you valid results. So I'm not going to be doing a lesson out of the book, but I'll be talking about it. So let me just think. Let's talk about, some of my kids are going to love this that I'm trying to draw. So this is... Yikes. Let's pretend that's a truck, a wheat truck. So this is kind of an example from my hometown. When wheat harvest comes in, just for those of you city kids that aren't sure about this, they fill all the wheat from the wheat harvest in the back of this truck, and they take it to the scale to weigh it, get it tested, and then they get paid for that wheat. So here's a problem with a sample. So in the past, the way they sampled the wheat, because the owners of the elevator need to know the moisture content and the test weight, and they need to know a lot of things about this wheat to see how good the wheat is to know how much to pay. And so what they did is they would always drive up to the elevator, and a guy would come out with a coffee cup, and from right in here he would always take one coffee cup full of wheat to test it, and he would use that as his sample. So let's use this to talk about just a couple of the words that we need to know. First of all, population. What population was he trying to describe? All of the wheat in this truck. Not the wheat in all of Kansas, not all the wheat in the world, but the wheat in this truck he needs to have a sample of. A sample is a smaller form of the whole population. He doesn't want to test every single grain in that wheat truck, so he takes a coffee can full right there, and that's what they test, and they grow it proportionally then to talk about the whole truck full of wheat. Okay? So let's talk about some problems that we have with his sample. This is what you call a convenience sample. It was really easy for the guy to just lean over, get one coffee cup from the very front corner. If it's too easy, that generally leads to a bias. And we have a biased sample here because too easy, that means it could easily be cheated, right? So if you had bad wheat, couldn't you fill up almost all of your truck with bad wheat and then just put a little bit of good wheat right at the top? And they would test good wheat and think that the rest of that truck full was good wheat. So out of convenience, they may not have a good sample of what is all the way out there. Okay? Some other ways that you could screw this up, I shouldn't say that probably, but some other ways you can mess this up is you could take what is called a voluntary response. Now, I'll just give you an example on this one, and then I'll give you a couple other examples. Could they just say, hey, bring in a little bit of your wheat? Well, if they just said bring in your little wheat, now they're not even taking the sample. They're saying, hey, you bring in the wheat that you want. Couldn't you pick the wheat from somebody else's truck that might be a better truck load of wheat, and you voluntarily bring that in? Well, a lot of times, that's not exactly what a voluntary response is, but that would be what it was in this example. I talk about like bands. So I pick out a boy band, like One Direction or something like that. If I said, you know what, raise your hand if you have an opinion about One Direction. What's going to happen is I'm going to have people that really like them raise their hand and people that really don't like them raise their hand, but I'm not going to have the people that just don't care one way or the other represented very well. And so if we're looking for a good sample, we want to make sure it's not too convenient. We want to make sure that it's not just the people that really care about it or really feel one way or another about it. We want to make sure that it is random, which means, let me go over that word, means everybody in the population has the same chance, same probability of being chosen. So every wheat kernel in here should have the same chance of being chosen if I want to truly represent this well. Okay? So let's talk about some random unbiased ways of sampling. One random is just a simple random sample, which means kind of like drawing names out of a hat. Everybody has the same chance. So here's what they do now. Now there's this mechanical arm that comes out and randomly chooses where in this truck it goes in, and then guess what it does? It kind of like a core sample. It goes down and takes a sample all the way top to bottom. Now do you notice? That's a whole lot harder to cheat because you don't know where this is going to be. And you're getting some of the top, some of the middle, some of the bottom. You're getting a better idea of what's going on in this whole wheat truck. So you can't really cheat it then because you don't know where the arm's going, don't know, and you're also going to get top to bottom results on this. So we would have what is called a simple random sample. Now, what I normally use for that is just names out of a hat. Everybody has the same probability of getting it. Okay. Another one is called a systematic random sample. Now, it's kind of hard to show you a systematic random sample with this wheat truck. But a systematic random sample means you have some way that everybody has a chance of being chosen, or everything has a chance of being chosen, but you do it like maybe every 20th person that walks through the door, because you don't always come in the same door, the same order, so every 20th person could be different on different days, so everybody that comes in has a chance of being the 20th, the 40th, the 60th, or the 80th, but that way we're sampling. We don't have to talk to everybody, we don't have to get information from everybody, so it becomes more feasible, but we're doing it in a systematic way. Okay? And these are ways to hopefully make it unbiased and random, and these are going to lead to more valid, now it doesn't guarantee this valid, but more valid inferences. Now we can make that and make predictions based on them. If it's too convenient, you don't want to make an inference based on that. So, for example, if I only talk to my friends, well, that's convenient, but don't my friends share a lot of things in common with me? Yeah, so we probably have a lot of the same answers, and so in that way I've biased my sample towards the things that my friends and I like. Or voluntary response. Only the people that really care about the issue are gonna give us a response, and so we've biased them in that way. Okay? So our goal here is to look and try to make it as random as possible. That means everybody has the same probability. Make it unbiased by getting a simple random or a systematic random response in that way. So let me just I will do a couple off of your guided practice. How about that? Just read them out loud, and we can talk about them. Zach is trying to decide which of these 3 golf courses is the best. He randomly surveyed, there's good, people at a sports store and recorded the results in the table. Is the sample method valid? If so, suppose Zach surveyed 150 more people, how many would he expect to vote for Rolling Meadows? That's a simple random sample. They did it randomly. They didn't just pick friends. They didn't do it just convenience, right? They talked to people at a sports store and randomly chose them, and so that would be pretty valid responses, right? And of course, I'm not going to go through the math of the numbers, but you could look at that and say, okay, they chose them randomly. We have pretty valid results. So let me read number 2. To find how much money the average American family spends to cool their home, 100 Alaskan families are surveyed at random. Of the family, 85 said they spend less than $75 per month on cooling. The researcher concluded that the average American family spends less than $75 on cooling per month. Is this conclusion valid? Well, they picked 100 families at random, so random sounds good, right? Problem is, oh boy, should I draw again on the same thing? Oh man, I don't want to draw Texas, Florida. Yeah, okay, terrible. And then Alaska up here. Okay, so the problem is to represent this entire population, they only talk to a small sample of Alaskan people. Does that bias the results? Heavily, right? Because do you think people in Texas have a little bit more of a difficult time heating or cooling their house than people in Alaska? Yeah, and wouldn't you want to be able to have Alaskans and Texans and Californians and Kansans and Floridians and New Yorkers and have all of these people have the same probability of being chosen? Doesn't mean that you have to have somebody from every state, but shouldn't everybody have a chance at this if we're gonna make an inference about all of the United States? And I didn't even include Hawaii down here. There's Hawaii. Didn't include Hawaii, but shouldn't all of these people have the same probability of being chosen if we're going to talk about the population, not being Alaska, the population being United States? Then all of the people in the United States should have that same probability of being chosen.